Hello dear students, in today's lecture we will discuss the introduction of basic probability. So this is the lecture number 2. We have already discussed in lecture number 1 of basic probability and their terminology. In today's lecture, the outline of the lecture is additional theorems on probability, conditional probability, independent events, discrete random variables, and probability distribution, continuous random variables and probability distribution, sampling distribution of sample mean, variance, and standard deviation. So let us start from addition theorem on probability. If A and B are the two events associated with the random experiment, then probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. If note that if A and B are mutually exclusive, then probability of A intersection B equal to 0, and in this case the addition theorem of probability becomes P of A union B equal to probability of A plus probability of B, because intersection becomes 0. This law can be extended to more than two events also. Then let us take example on addition. A drawer contains 50 bolts and 150 nuts. Half of the bolts and half of the nuts are rusted. If one item is chosen at random, what is the probability that it is the rusted or a bolt? So A we chosen along rusted, B we chosen is bolt. Clearly probability of A PA is 100 divided by 200, because 200 with the total sample. Probability of B is 50 divided by 200, and probability of A intersection B is 25 divided by 200. So the required probability is probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. After substituting the value of PB and PA intersection B equal to 5 by 8. Then the conditional probability of B given by A, PB by A equal to probability of A intersection B divided by PA, multiplication theorem on probability. After cross multiplication, we get probability of A intersection B equal to PA into PB by A equal to PA intersection B. Note that if A and B are the two events associated with the random experiment, then probability of A intersection B equal to PA into PB by A if PA is not equal to 0. Second, PA intersection B equal to PB into PB by A if PB is not equal to 0, means that probability of B divided by A means probability of occurrence of B divided along with A means A has already occurred. Now example, what is the probability that the total of two dice will be greater than 8 given that the first die is 6? Same, first we take the A equal to, let A be the first die, that is 6, and B be the total two dice greater than 8. A and B will be 6 3, 6 4, 5 6 and 6 6. There are 36 outcomes when we throw two dice. So probability of B intersection A equal to 4 by 36 equal to 1 by 9, and probability of B by A equal to probability of B intersection A into by PA equal to 1 by 9 divided by 1 by 6. It becomes 2 by 3. Then after the independent events are said to be independent if the occurrence or non-occurrence of one does not affect the probability of occurrence or non-occurrence of the other. So let A and B be the independent event associated with the random experiment, then probability of A intersection B equal to PA into PB. This law can be extended more than two events also. Now example related to the independent events. A bag contains 5 white and 7 red and 4 black balls. If 4 balls are drawn one by one with the replacement, what is the probability that none is white? Solution. Let A, B, C, D denotes the events of not getting a white ball in first, second, third, and fourth draw respectively. Since the balls are drawn with replacement, therefore B, C, D are independent events such that probability of A equal to probability of B equal to probability of C equal to probability of D, all are equal. Since there are 16 balls, there are 16 balls, out of which 11 are not white, therefore probability of A equal to 11 divided by 16. Similarly, probability of B is also 11 by 16 and probability of C is also 11 by 16 and probability of D is also 11 by 16. Now the required probability of A intersection B intersection C intersection D equal to PA into PB into PC into PD equal to 11 by 16 whole to the power 4. So this is the required result of the probability. Now after independent event, random variable. A random variable is a variable whose value is a numerical outcome of a random phenomenon. Usually it is denoted by capital XYZ. Discrete. A random variable has an finite or countable infinite possible values. Continuous. A random variable has an interval and for its set of possible values. So this is the all about a random variable. Example, a die is rolled once. We let the outcomes of the experiment, then the sample space of its experiment is the 6 element set, that is U equal to 1 to 6, where each outcomes like 1 to 6, suppose E be the event 2, 4, 6, corresponds the statement of the result of rule is an even number. Adopting the this conversation means that we assign a probability of 1 by 6 of each of the 6 outcomes, that is 1 by 6, for 1 less than equal to I less than equal to 6, and even outcomes equal to odd outcomes, that is also 3 by 6 means 1 by 2. Then after expected values. Expected values of x or population means mu equal to E of x equal to sigma xi into pi. So this is the expected value of the data. Now variance of x equal to sigma of x square into p minus mu of square. Working rule to calculate the variance. First we square each value and multiply by its probability, then sum of the values means sigma of x square into p, and then we subtract with mu of square. Mu of square means expected value, means mean. For example, find the mean and variance. This is the value of x, this is the probability, respective probability, and then after we define x square into p. X square into p means first we square the value of x individually and then multiply with their probability. It becomes 0.1. 2 of square, that is 4. 4 into 0.1 means 0.4. 3 of square means 9 into 0.1, it becomes 0.9. 4 squared means 16. 16 into 0.1 means 1.6. 25 into 0.1 means 2.5. And 6 square means 36. 36 into 0.5, that means 18. So the mean equal to mu equal to sigma of x square into p. After addition of this value, we get 23.5. So this is the value of mu, and variance, the formula of variance is sigma x square into p minus mu of square, means 23.5 minus 4.5 of square. This is the mean value. equal to 3.25. Therefore, the variance is 3.25. Then after a standard deviation equal to under root of variance. The formula, again I repeat the formula, standard deviation equal to under root of variance. Example, find standard deviation of the previous data, that is the value of x is 1 to 6 and probability, respective probability is 0.1, 0.1, 0.1 and the last one is 0.5. X square p is this one. So the standard deviation equal to under root of variance, that means under root of 3.25, it becomes 1.803 approx. So this is the standard deviation. Note, a random variable is a variable whose possible values are numerical outcomes of a random experiment. Mean means expected value, that is mu equal to sigma of xi into pi, x into p, and the variance is under root of summation of x square into p minus mu of square, and standard deviation is under root of variance. So thank you.